temperature of Venus is 900 degrees Fahrenheit. That's hotter than a baker's oven. Lead would be molten at that temperature.
The planet Venus has revealed a stunning secret. It is still geologically active, with active volcanoes that are continuously reshaping its surface. So you can suggest that the planet is not a static, dormant world, but one full of dynamic processes, just like our rocky planet Earth. At first glance, Venus and Earth seem like twins. Venus is nearly the same size as Earth, with a diameter of 7,520 miles compared to Earth's 7,917 miles. Both planets have a similar rocky composition and likely formed around the same time, more than 4.5 billion years ago. Yet, despite these similarities, Venus has evolved into an entirely different world. It's a hostile, scorching place that stands in stark contrast to our green and blue Earth. One major difference is their location. Venus is much closer to the Sun, orbiting at an average distance of 67 million miles. This closer proximity means it receives almost twice the amount of solar energy as Earth. However, it isn't just the Sun's heat that makes Venus so inhospitable. Its thick atmosphere, made primarily of carbon dioxide, traps heat through a runaway greenhouse effect, creating surface temperatures of about 880 degrees Fahrenheit. This makes Venus the hottest planet in the solar system, even hotter than Mercury, which is closer to the Sun. Venus's atmosphere is filled with clouds of sulfuric acid. These clouds make it impossible for visible light to penetrate, so scientists must rely on radar to study the planet's surface. The dense atmosphere also creates enormous pressure, about 90 times greater than Earth's. Standing on Venus would feel like being 3,000 feet underwater in Earth's oceans. These conditions make Venus one of the most challenging places to explore in the solar system. Venus is not only extreme in its environment, but also unique in its behavior. Unlike Earth, which rotates counterclockwise, Venus spins in the opposite direction. This phenomenon is known as retrograde rotation. This means the sun rises in the west and sets in the east on Venus, although you'd have to wait a very long time to see it happen. A single day on Venus lasts 243 Earth days, longer than a Venusian year, which is only 225 Earth days. This slow, backward spin is one of the many mysteries surrounding the planet's history. But while the surface of Venus rotates slowly, its atmosphere behaves very differently. High above the planet, winds whip through the atmosphere at incredible speeds, completing a full rotation around the planet in just 4 Earth days. This is called superrotation, and it drives winds near the equator that reach speeds of 335 miles per hour. These winds are so strong that they evenly distribute heat across the surface, making Venus uniformly hot regardless of whether it's day or night. Another striking feature of Venus's atmosphere is its density. The air on Venus is so thick that it weighs 100 times more than the Earth's atmosphere. This incredible weight traps heat and creates a phenomenon called thermal inertia, where the surface temperatures remain steady over time. Even during the long Venusian night, the temperature doesn't drop significantly. Scientists often compare this effect to Earth's oceans, which can absorb and retain heat, moderating the planet's climate. On Venus, this effect occurs on a much larger and more extreme scale, with the thick atmosphere acting as a blanket that never lets the planet cool down. Venus and Earth likely started out with similar conditions billions of years ago. Both planets were formed from the same raw materials in the early days of the solar system and were shaped by similar processes, including intense volcanic activity. For Earth, this volcanic activity helped create the conditions needed for life by releasing water vapor and other gases into the atmosphere, which eventually led to the formation of oceans. But on Venus, things took a much different turn. Scientists believe that Venus experienced massive volcanic eruptions early in its history, releasing enormous amounts of carbon dioxide into the atmosphere. Over time, this buildup of greenhouse gases caused temperatures to soar, creating a runaway greenhouse effect. Any water that may have existed on Venus would have evaporated, leaving the planet dry and barren. These eruptions may have contributed to the thick, toxic atmosphere that now blankets the planet. Unlike Earth, Venus does not appear to have plate tectonics. On Earth, plate tectonics drives the formation of mountains, earthquakes, and volcanoes, and it plays a critical role in regulating the planet's climate over long timescales. Without this process, Venus's crust may have become stagnant, trapping heat below the surface and leading to periodic bursts of volcanic activity. This lack of plate tectonics is a major puzzle for scientists, as it makes it much harder to understand the planet's geological history. Humans have been fascinated by Venus for thousands of years. Ancient astronomers tracked its movements across the sky and have marveled at its brightness as both the morning star and the evening star. These observations laid the foundation for our understanding of the solar system, but it wasn't until the 20th century that we began to explore Venus up close. The Soviet Union was the first to successfully send spacecraft to Venus. Beginning in the 1960s, the Venera program launched a series of missions to study the planet. In 1982, Venera 13 became the first spacecraft to land on Venus and send back images of its surface. The images revealed a rocky, desolate landscape, confirming that Venus's surface was as harsh as scientists had suspected. However, the spacecraft survived for only about 2 hours before succumbing to the planet's extreme heat and pressure. Around the same time, NASA conducted flyby missions to Venus with its Mariner spacecraft, which provided valuable data on the planet's atmosphere and magnetic field. But the most significant contribution to our understanding of Venus came from the NASA's Magellan mission, which entered orbit around the planet in 1990. Magellan used radar to map over 98% of Venus's surface, revealing a world dominated by vast volcanic plains, towering mountains, and deep canyons. Magellan's data was a treasure trove of information, but at the time, scientists lacked the tools to fully analyze it. The mission ended in 1994, and much of the data was archived for future study. Decades later, advancements in technology and new methods of analysis have allowed scientists to revisit this data, uncovering evidence of active volcanoes and reshaping our understanding of Venus's geology. There's been a big question in the history whether the planet's volcanoes were dormant or active. The fresh analysis of data from NASA's Magellan mission answers this question. Venus has active volcanoes that are reshaping its surface. The discovery was made possible by 2 groundbreaking studies. A team led by Anna Gulcher, a planetary scientist, and another led by Robert R. Herrick, an expert in planetary geology, revisited the data collected by the Magellan spacecraft. Herrick's team focused on a volcanic region called Atla Regio. That's the home to 2 of Venus's largest volcanoes, Aza Mons and Mont Mons. The team identified significant changes in a volcanic vent over a relatively short time. The vent appeared to have doubled in size in less than a year, between 2 radar observations made in 1991. This sudden expansion suggested volcanic activity, with new material, likely lava, emerging and reshaping the vent. The discovery of a possible lava lake further confirmed that Venus is not a static, inactive world. Instead, it's geologically active, with heat and pressure from its interior still driving volcanic processes. The work of Gulcher's team further supported these findings. They used advanced algorithms and radiostereogrammetry, that's a technique that creates 3-dimensional images from radar data to create detailed topography maps of Venus. These maps revealed subtle changes in surface features, pointing to recent lava flows and shifts in terrain. A sophisticated image processing method called orthogonal transformation allowed researchers to see Venus's landscape with unprecedented clarity. Together, these methods provided strong evidence that Venus's surface is constantly changing due to volcanic activity. This discovery not only confirms that Venus has active volcanoes, but also raises questions about how these processes influence the planet's atmosphere and evolution. Volcanic eruptions likely release gases into Venus's dense atmosphere. contributing to its already extreme greenhouse effect. Understanding these interactions is key to piecing together Venus's history and its divergence from Earth. The confirmation of active volcanoes on Venus is more than a scientific curiosity. It has far-reaching implications for planetary science and our understanding of rocky planets. First, it establishes Venus as a geographically active planet, joining Earth and possibly Mars in this category. This finding challenges the idea that Venus is a dead world and suggests that it may still harbor processes similar to those that shaped the Earth's early history. The discovery also has implications for the search of life in extreme environments. Although Venus's surface is far too hostile to support life as we know it, its volcanic activity could create pockets of less extreme conditions. For example, volcanic vents might release heat and gases that could theoretically support microbial life in the upper atmosphere, where temperatures and pressures are less extreme. The idea remains speculative, but it highlights the importance of studying Venus to explore the boundaries of habitability. The discovery of active volcanoes has reignited interest in Venus and highlighted the need for new missions to explore the planet in greater detail. Two upcoming NASA missions, Veritas and Da Vinci Plus, aim to answer some of the lingering questions about Venus's geology, atmosphere, and evolution. The Veritas mission, whose name stands for Venus Emissivity, Radio Science, INSAR, Topography, and Spectroscopy, is designed to create the most detailed maps of Venus's surface ever made. Using advanced radar and infrared imaging, Veritas will study the planet's topography, surface composition, and gravitational field. The mission aims to uncover the processes shaping Venus's surface, from volcanic activity to tectonic movements. By doing so, Veritas will provide crucial data to compare Venus with Earth and other rocky planets, helping scientists understand why these seemingly similar worlds took such different paths. The Da Vinci Plus mission, short for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, will focus on Venus's thick atmosphere. It will send a descent probe to plunge through the atmosphere, collecting data on its composition, temperature, and pressure. Da Vinci Plus will also capture high-resolution images of Venus's surface during its descent, offering a close-up view of the planet's geology. One of the mission's goals is to determine whether Venus ever had water and what role volcanic activity played in shaping its atmosphere. The mission's findings could provide valuable insights into the history of water on rocky planets, including Earth. Despite the promise of these missions, they face significant challenges. Funding for planetary science missions is limited, and the timelines for these projects are long. Veritas and Da Vinci Plus are expected to launch in the 2030s, leaving a gap of several years before new data from Venus becomes available. Meanwhile, international missions such as Europe's Envision spacecraft could complement NASA's efforts, but similar funding and scheduling challenges apply. That was it for today. Don't forget to subscribe to the channel. And if you're interested in knowing more about the planets, watch our video on what did we find in the first real images of Triton. See you in the next one. Bye.